All right, for this group of questions, we're dealing with slope fields, and it's kind of like slope field matching, because each of these questions, 30 through 34, wants us to answer which slope field goes with it. So let's do 30 first. This is one that we've seen before. If the derivative of a function is equal to the function itself, then there's only one function that works like that, and that will be e to the x. And as we can see from number 2 here, we have an exponential growth slope field. So the answer to 30 will be 2, and we have used that slope field. Let's see, for 31, I need something where the slopes are driven by both the x and the y values. So that means if I read up and down, or I read across, I should have the slopes changing. Well, that's not happening in number 1, because actually it looks like my x values alone are driving this slope field. Same thing for number 3. X values alone are driving it. Number 4 could work, and actually number 5, the x values alone are driving the slope field. So my answer to 31, by process of elimination, must be 4. And actually, if you were to separate, integrate, and solve this, you would get a circle equation, which is what it looks like is happening in this slope field. So then sine, you actually just want to go with number 3, because the integral of sine will be negative cosine, which is exactly what this curve is of here. And I didn't do a very good job of drawing in the negative cosine, but I'll try better. Negative cosine just means I have this dip right here, then it goes up, etc., etc. So we've finished that one, and the answer is C3. So then, which one goes with y prime equals 2x? Well, if I integrate that straight up, I get that y equals x squared. So that is going to go with, all right, we just got interrupted by a fire drill. So back to it. Number 33, if you integrate that, you'll get x squared, which is the quadratic in number 1. There's your quadratic. So 33 goes with 1. And by process of elimination, we know that 34 is going to go with 5. And really, that's the only way we're going to get that one, because that is a crazy function that we cannot integrate anyway. So then number 35, which is this right here, it says a particular solution curve of the diffy q that's in 2. So that is the exponential growth model up here. Goes through the point 0, negative 1. What is the equation of that solution curve? So let's just pretend that this is the solution through the point 0, 1. So that's an exponential growth flipped over the x-axis. So that should be this equation, negative e to the x, which is choice A.